Hello friends, you're currently inside a building, aren't you? The building is a structure that is not flying in the air, but supported by soil through its foundation. The analysis that evaluates the collective response of the three linked systems, the structure, the foundation, and the soil, is called soil structure interaction analysis.
To conduct a soil structure interaction analysis within a design setting requires both geotechnical and structural engineers. Geotechnical engineers study the soils, characterize shear wave velocity profiles, and shear strength parameters. Also, Poisson's ratio, hysteretic damping ratio, static, and dynamic springs are needed for modeling soil properties. The parameters then will be implemented by structural engineers who will design the structures, their slabs, beams, columns, and foundations. The engineers will also find structure response parameters such as building period and mass, foundation springs, and dashpots. The structure to soil stiffness ratio can be used as a relative measure for determining when soil structure interaction effects will become significant.
You may know that any movement in structure will affect the soil and vice versa. If we remember, one of Newton's laws of motion states that for every action, there is an equal and opposite reaction. The principle also applies to soil and structures. Understanding of soil structure interaction principles varies widely across both the structural and geotechnical engineering disciplines. Substantial research has been available for many years, yet there is relatively limited implementation of soil structure interaction in engineering practice. This is partly because the analysis is complex and very time-consuming. Thanks to computer software such as Shake, SAP, Plaxis, and FLAC, 2D and 3D numerical modeling cut down a significant amount of time for the analysis. Well, and engineers have fun seeing this. These buildings are actually two case studies of soil structure interaction. Soil structure interaction effects are more pronounced in soft soils, and many structural engineers are aware that foundation input motions can differ from free field ground motions. Soil structure interaction concept is not only applicable for buildings, but also bridges, retaining walls, dams, and other structures.
Engineers associate several benefits with modeling of soil structure interaction effects, such as gaining a better understanding of the distribution of forces, displacements in soil and structures, as well as gaining additional insight into the foundation design. Improved communication and collaboration between geotechnical and structural engineering disciplines is important for better experience in soil structure interaction implementation and standards of practice.
Created using Powtoon.